Yeah, that only took like what, 10 minutes? All right. Y'all are used to Godot. The Godot project's load in like 2 seconds. They just open it up and it just works. All right. Welcome everyone. Today's gonna be like a very simple workshop, but we're gonna try and go sort of very detailed and step by step. I tend to make these workshops very sort of abstract and conceptual. Today we're just going to play around in this and try to make some cool physicsy things. Um, Remind me again, y'all are CS majors, AT majors? AT?
Yeah,
CS. Have you taken Lineage yet?
I'm taking it right
Okay, so you're going to know everything. And Lorenzo, you know everything. So if something breaks, I'm in good company here. Um, Okay, scale of 1 to 10, how kind of confident are y'all in like I can make like a 2D platformer character just like right off the bat? You better be you better be able to do that right off the bat, yeah. Um,
now. I guess that.
7 probably. 7. All right. So we're just going to start off with that. Um, and I'll kind of I guess ask y'all some kind of conceptual questions as we move through this. First of all, I'm going to go in here and I'm just going to make my character. Or start with a 2D object and square. Nice way to kind of have a little floor here. And I'm going to put a box collider 2D. I need to scroll there. And then this will be my floor. And then I'm going to go in here. And then player will also be a circle, why not? And then I'm going to do two things to this. I'm going to add a rigid body 2D. And then I'm going to add a collider 2D. And then if I go in here and press play, it falls. Is so far so good with all of this? Okay. Yeah, y'all come to my workshop, so y'all know everything. Y'all are experts at this. One thing I'm going to do before I switch anything else, I find it extremely impressive that the Unity devs managed to pick precisely the ugliest shade of blue imaginable. Um, that was like scientific right there. So we're just we'll do something like that. We'll keep it minimalistic, and then let's see, I'm going to rename this to player. And then we'll make our player like something like that. All right. So now we have this. But now we look at the settings we just added, and some of these start to get confusing. So first of all, I think the default gravity scale is way too slow. This is like if you're on the moon. So the first thing I always do is just increase the gravity scale. There's no shame in doing this for some reason. It sets it to be some like realistic value of like negative 9.8 units per second. For most games, I find that's way too slow. So the first thing I always do is just bump that up a bit. Hello, welcome. Okay, who feels confident that they can explain what this option does? What are y'all? Are y'all?
Here.
Mhm. What do you? Yes.
I'll give it a shot. So,
Mhm.
from just like the name discrete and continuous, I'm imagining that discrete probably only checks for collisions on every physics update, whereas
Yes.
continuous checks in between every physics update, like every frame.
Yeah, exactly. So, you're right, because when the physics engine moves the player, it's going to say, okay, well, I'm going to move the player here, this frame, and then the next frame, my player is here, the next frame, my player is here. That can sort of jump spots. So if you have, say, like a really small projectile, and that small projectile is colliding with a very thin collider, right? The chance of that projectile just phasing through the wall is very high because it's just going to step right through it, right? So what the continuous option does is it's going to check in between the frames, and it does some fancy math to do that. We don't have to know exactly how that works. But the point is this is expensive. So use it when you have to, is the point. The physics engine is by default. Do you remember the default refresh rate of the physics engine? It's 50 frames per second, yeah. So by default, the Unity is going to try and keep that nice and high for you. So you don't have to just spam this everywhere, right? If your player is like itty bitty and small, then maybe this player is like, I don't know, it's a big player, so I'm not going to bother clicking this. All right. So we understand, and for now, I'm just going to keep it discrete. We'll come back to sleeping mode in a bit. Who wants to try and guess what interpolate, extrapolate, none means? It's a very similar idea to sort of the motivation behind the collision detection, right? What does it mean to interpolate something? Just mathematically, if I give you 2 points and I say interpolate between them, you step through it, right? Yeah, so that's what interpolation means. It means I give you an A and a B, and interpolation means sort of the points in between that. So it's basically the equivalent of the motivation for collision detection, why we do this, but it's for movement. We do it for movement. So in the same way that it's going to step from one point to the other, interpolation is going to add some extra fancy math in between the physics updates, because oftentimes your frame rate is quite a bit higher than 50 frames per second, right? Like I would hope that a game this simple would be running at least a couple hundred frames, right? So oftentimes if you just, yes.
If you have the like another player's position being updated,
Yeah.
but like they have high latency or something, having it interpolate makes it on the client side look smoothly when the update moves.
Yeah.
Even though it's not technically jump.
Yeah, exactly. So when you get into networking, all of this stuff becomes even more important because you don't want to. You have to be careful with what you replicate and what you don't replicate. So oftentimes games will use tricks like interpolation to sort of smooth out player movement between client and server. We gotta get you to do that network workshop sometime soon. Yeah. I know next to nothing about networking. I actively avoid it. Lorenzo here is my JO and he's an expert, so he'll take care of y'all there. But yeah, it's basically that. We're gonna do some extra fancy math and make those updates between the frames look a little bit smoother. So I leave this on for the player simply because when I interact with the player, if the player is jittery, I notice, right? Once we get a player controller moving around, we'll turn it on and turn it off. It might be visible here with the screen recording, and on here it's sometimes not visible, but it's going to be a somewhat of a trust me bro situation with when you play it, you notice it, and y'all can try this yourselves. But for players, I always leave interpolate on. Okay. This one is slightly trickier, I think. Who wants to take a wild stab at what this setting does, the sleeping mode? Yeah?
Is it like I'm assuming the rigid body has like the start of physics. It has to start at some point, so start and wait just when the game starts, it starts the rigid body physics.
Yeah.
Whereas start sleep would just not have it on and then you have to start it and wait.
Mm.
And never sleep, I guess, would just mean it's always on, regardless of
So you're close. What do you think it means for like an object to be asleep in the context of like a rigid body? Like what would make sense for sleep to what does it mean to be on?
I guess it's not moving.
It's not moving, right? So basically this is an optimization trick that the physics engine has built in. Basically, if you have an object that's sort of stationary, not moving, for a while, and the game engine decides when exactly it wants to turn this on or turn this off, right? So this is something that's managed internally. If you have an object that's just kind of sitting there, right, it makes very little sense for the engine to spend time calculating like its velocity, right, and like trying to calculate all the forces and the angular momentum on the object, right? So basically what it's going to do is it says, look, this object has been sitting here for the last 5 minutes. I'm not going to bother calculating all this extra stuff for it. I'm going to put it to sleep, right? So it means it's going to simplify the calculations that get done on that object. Now, the cost of this is that what happens if suddenly that object that's just been sitting there for 5 minutes gets hit, right? You have to wake it back up again. And that adds some extra overhead that the engine has to do, right? So when we start awake, it just starts awake by default. When we start asleep, it's just going to assume that it's going to be stationary. And what never sleep does is it means that no matter how long I sit there stationary, don't stop doing those calculations, right? So once again, this is a very sort of situational sort of thing. The key point is you don't want to spam this on just everything and say, why would I want anything to sleep? Everything will just stay awake forever, right? You don't want to do that because sleeping is actually an important optimization that the engine will do. It saves a lot of computation time when you just kind of have stationary rigid bodies. But specifically for the player, I like to put it on never sleep. Simply because, I don't know, imagine like you're like listening to some dialogue and then so your player is standing there for like 30 seconds doing nothing. I'd like the rigid body to stay awake. And there's only one player, so like who cares if it has to do some extra calculations, right? But other than that, I would say leave the set to default, yes.
Is sleeping a strategy just the engine, or it could be like the program like manually change the sleeping?
Ooh, I don't know if you can manually put an object to sleep. That would be interesting if you could. Um, I don't see why not. Like they might as well expose it. Like if that's not, like submit a feature request to Unity. Why not? That would be a useful feature. I don't know if you can manually do it. This is just the sort of thing that you can kind of let it take care of it. Yes.
I have a question.
Yes.
I just never thought of this, but this is different from the actual like awake function that you could call, right?
Yes.
Right. Because that one happens when you enable the object, right?
Yes.
Is it just a different awake?
I'm 99% sure it's just a separate concept. Yeah. The awake you're referring to is, when you have a script and you have like start and you have fixed update. Have you all used awake at all? Yes. Awake. Yeah. So that's kind of like the thing that happens when the object is first enabled. It's used kind of if you want to do some setup before the first frame. So actually, I never thought of that. They're kind of separate things. The awake that Lorenzo is referring to has to do with the object lifecycle. But yeah, so for players, I like to leave this at just never sleep. Anything else, I just leave it at the default and let the engine handle it unless I have some specific reason. And you can also give it a hint and say, okay, go ahead and start asleep if you're pretty sure the rigid body is just going to stay there, right? All right. Everybody's following so far? All right. Let's go back to this setting. We didn't talk about extrapolate, right? So if interpolation is sort of the spaces in between those points, what do you think extrapolate might do? Yeah.
Interpret like the points like side.
Basically, yeah. And that's like, it's tricky because like, what does that even mean, right? Um, the use case for this is if you have a really, really fast moving object, um, say like a projectile, right? Uh, and it's appearing to be sort of not so smooth, I recommend turning this on. That's going to allow the engine to basically catch up with really fast moving objects and basically just display those smoothly. If you try and turn on extrapolate on a slow moving object, you will be in pain. It will not like you. It will stutter. It will, it's bad. I don't recommend doing it, but we can try it. So that's pretty much what all those settings do. All right. So now you all basically understand. These are sort of the most difficult settings, in my opinion, to understand because they require you to understand something about how the engine works internally. These should be relatively self-explanatory, but we'll go over them pretty quick, right? Mass is something I almost never use unless it's like I really have like a physics-based game where I'm like launching stuff and like I don't know, think like Angry Birds or something, right? Um, Linear damping is also if I push an object if I push an object, right, and linear damping is 0, it's just going to keep going off into infinity. However, if linear dampening is higher, there's going to be some drag as it moves through the air. So you can kind of think of this like a sort of air resistance. When you just sort of push an object, it'll kind of come to a stop as it moves linearly. Angular damping is the exact same thing except for torque. So if I add a torque to an object and it starts spinning, it will have some dampening. It won't just turn forever, right? Gravity scale we already went over, and that's pretty much it for the rigid body. There's some extra stuff. These are sort of the hidden objects we have. Layer overrides. I don't think I've ever used this. And this is actually quite useful because if our player bumps into something, we want it to stay upright, right? So one very useful thing is to just turn on freeze rotation on the z-axis because once again, if our player bumps into something, we don't want them to tip over and fall, right? Quick overview just to check for understanding. Why is rotation on the z-axis on a 2D game? What does it mean to rotate on an axis? Yeah?
It's like the axis around which it's rotating. Right?
Yes.
C is the depth.
Yes.
So rotating right would be rotating clockwise or counterclockwise.
Exactly. Yeah. So the z-axis points into the screen, right? This is different from some other game engines where the z-axis is up. I think that's weird personally. Z-axis to me is depth. So you have the axis that's pointing into the screen. So what it means to rotate around that axis is what you would see in 2D, right? Similarly, to rotate around the y-axis would look like this in 2D. And to rotate around the x-axis would be to sort of flip forward, which doesn't quite make sense in 2D, but you can use it. So this is why the z rotation is what we freeze here. I don't know why you would ever put a rigid body on something and then freeze its position, but you can do that. There's probably special cases. Actually, maybe, I don't know, but if you might want to, if anyone thinks of a case where they would freeze the position of an object, there definitely are. I just can't think of any off the top of my head. All right, how are we doing so far? Any questions? All right, let's start coding. So now that we kind of sort of understand each of these things, I want to go over, my goal for today is to, number one, make a simple player controller. Number two, deal with the problem of sort of when you have a player that's controlled, like via the keyboard, let's say, where you sort of are constantly manually overriding its velocity, how do we combine that sort of system with also external forces? So there's going to be, that's kind of the problem I want to explore because that tends to cause some frustration. So that's what we'll do. First of all, I'll go in and add a new script. I'll call this player controller. Will give me an object option to add a new script. And then I go and open this up. All right. If I forget C# during the course of this workshop, y'all can help me out a bit. But I think most of y'all are pretty comfortable with this, so we'll kind of zoom right past it. But in case any of y'all are new to this, I'll kind of walk y'all through the code. So let's start with a serialized field, float for, let's do like a ground speed, and then let's do kind of a jump force. Quick reminder, what does serialized field do? Yes, exactly. Why would we use this instead of public?
Because public, yes, it lets you do it in the editor, but it also has the variable to the global namespace, so it can be accessed outside, and you don't always want that for everything.
Exactly, yeah. The reason is what we call encapsulation. So public variables are accessible anywhere. Conventional object-oriented wisdom says that you should keep everything as private as possible to avoid just stuff getting modified around. So serialized field is the answer to that. It lets us expose something into the editor without exposing it to our entire code base. Right? So I'll have a move speed, I'll have a jump force. Of course, I need a reference to the rigid body. So we'll go rigid body 2D. I just call it RB. Some people think abbreviations are evil. I think RB is self-explanatory. What else do we need? That lets us start it. I'll make a float move input. It's going to go under axis. All right, so we're going to start off by getting a reference to our rigid body, and then we need some sort of move input, which is going to go input dot get axis raw. I'll get it on the horizontal. That's how you spell horizontal. And then we'll go in here very quickly and do our fixed update. And then we'll say that RB dot linear velocity x is equal to move input times move speed. All right. Is there any sort of confusion with what we did here? All right, pretty standard. All right, so we'll go back into the editor, let this compile. And then we, of course, want to move slightly faster than 0. So I'll do like 5. And we also go here. And we're moving around. Okay. Common frustration with Unity. I don't know if it's always that this happens to me or if this happens to everyone too. Y'all see this like very tiny gap right here? I don't know why it does. My thinking is that the distance between the collider of the player and the collider of the actual ground is so small that it's like less than the distance of one physics step. I feel like the engine should be able to deal with that, but maybe it doesn't. And here you can actually kind of see it's like they're definitely not colliding there. But what I do is I just say, okay, size is 0.98, size is 0.98, and that usually fixes it. This is only really a problem when you're dealing with like squares and stuff, and then there the problem goes away, right? If you're dealing with like sprites, it's like, okay, this is not so such a big deal. But with squares, I use squares a lot because I can't do art, so I end up usually having to to make this like 0.98. But yeah, let's add some jumping. So jumping is a little bit more complicated. I'm going to start going in here and adding a layer. And I'm going to go in here and I'll pick layer 3. I actually don't know why they leave layer 3 empty. Quick little quiz. Why do you think there's just a slot here for 31, for 0 to 31 layers? Yes.
Is it layer like orbit field or something like that?
It's exactly that. It's a bit mask. So, if you think of like a 4 byte integer is just 32 bits, which means we have 32 ones and zeros. And the way that Unity is going to check whether something is part of a layer or not part of a layer is literally just checking what bit it's part of. That lets it like do these layer checks very, very quickly. And it also lets you do a layer mask where, say if I'll go back here just to kind of illustrate the point. Let's say we only have 4 layers, and then I enable these layers. If I want to check if my layer is a part of this, it's a very simple bitwise AND. AND operation to check if, for example, hello. For example, if I want to check if this layer is enabled, so this second layer is enabled, I can take my layer mask, which is just a set of ones and zeros, I can AND it, and if this turns out to be a 1, then we know that it contains that layer. So basically, it lets you do these layer checks very, very quickly. The downside of that is we're limited to 31 layers only. You might be asking what happens if you want more than 31 layers, then you should probably rethink what you're doing if you need more than 31 layers. That, or you just build your own system. You're like, I'm going to make a long, and this will be my bit mask, and then I'm going to build a layering system on top of that. How that works, I don't know. I've never used more than like 5 layers. The what? You could also use tags. You could make like a tagging system, right? How would you integrate that with like, say, like a raycast?
It's not as good as layers. You would get the player, get its game object, and then check its tag.
Yeah.
Whatever your pick is.
Is this from personal experience?
For an old project. Yeah.
I see. Yeah.
But that's not the best way to do it. So.
Do you think it would have been like possible to like refactor it to be only like to fit within the mask?
Absolutely.
I see. It just kind of ballooned.
Yeah.
That's so real. That's
Everyone starts somewhere.
yeah. I've done absolutely atrocious things. My game jam code will never see the light of day. That's yeah. So yeah, I mean, it is possible. So if you just say, I want like a bajillion layers, you make a tag system, life moves on. Clean code is not real. Yeah. Actually, this is side tangent. Has anyone seen? Have people here seen Celeste's player controller? I think I've shown this in here before. This is brave of them to put online. Let me just. Slightly faster. I won't even. I want to sit down and like read through this one day and just see what they were thinking.
I just realized that's all an update. Hey, we got that.
We got done. I gotta love sound 1, sound 2. But yeah, so that's kind of a nice reminder that nothing we do is real, and you can just kind of do that and get away with it. Anyways, back to adding a jump. We're getting there. Only like 5,000 more lines to go. Cool, so we have a layer, right? And so I add my ground layer, and then so I go to my floor, and then I go in here, and I assign it my ground layer. And then so when I go into my player, right, in order for my player to jump, I want to be able to detect when its feet are touching the ground, basically. So very simple way of doing this is to just have a serialized field. I'm going to have a transform, call it feet position, and then I'm going to have a serialized field for the layer mask, and I'm going to say ground layer. And then in here, we're going to check if we've pressed space, if input.get button down, or sorry, get key down, key code space. And then we're going to check is grounded, so I'm going to make a boolean for this. Is grounded. And is grounded is going to be set to, this is going to be physics2d dot overlap. I want circle, overlap circle, and then this is going to take in, I always forget it takes in a point, which is position dot position. It takes in a radius, very small radius. You can kind of play with this, and it depends on on what exactly we want. It's going to take our layer mask, and I believe that's all we should need. So we're going to check if we've pressed space and is grounded, then we're going to sort of allow the player velocity to go up. So we're going to say RB dot linear velocity y is going to be set equal to jump force. So we're going to have an instantaneous change in the velocity to just move straight up, right? And then so I'm going to go in here. 0.02 might be, it'll be fine. It's been a while since I've done physics 2D overlap circle. But the jump force, we'll set it to like a -10. I have to go in here and I have to create, we're going to create a child of this object, and I'm going to call it feet position. And then go in here, go to my player, and then we can see that this is kind of hanging around in the center. We're going to move this down to -0.5. So it's just sitting right there. Okay? And then we're going to go to the player, assign the feet position here, and then the ground layer, you can see it'll just have me select what I want it to be. I'm going to say ground. And now if I go and I follow and I press space, I can get a very tiny little hop, right? Does anyone see any potential problems with what we've done here, specifically in the case that I do? Specifically in the case that, let's say I have another floor up here, and it's like a tiny little, like itty bitty platform. I'm going to go right here, something like that. I'm going to go here, and I'm going to try and jump, and nothing happens. Does anyone have any ideas why this happens? Yes.
Usually has from the center, if I remember.
Yes.
It's kind of off center, so it's not going to take that very anymore.
Exactly. So if you remember, we're basically doing a small little circle cast right here. Right? So this is what determines whether you're on the ground or not. You can see my player is standing here, and it's like on the ground, but it's not actually on the ground. So how do we deal with this? You can make the circle bigger, but if I make the circle bigger, it's also going to kind of come down into here, right? Right. Other ideas? Yes. Box cast, exactly. Yeah. I was going to wait for someone to say that we can just do 2 ray casts here, and I was going to say, haha, gotcha, what if we're right here? But no, exactly, we have box cast. So we have overlap. We have overlap box, and I always forget the API for this. So we have point and then size, which we can do here. Overlap box. Lindsay, do you remember the API for this?
It's just a vector 2.
Oh, it's a vector 2. I was like, wait, why is this a float? Yeah. Okay, so then we want the size of this to be 1 in sort of length, and then I'll keep the sort of 0.02 in depth. And then now if we go back, our box should be sort of happily handling all of these corner cases. All right, so we have a simple player controller. We can jump around and do all of these fun things. Okay. Let's see, what should we add next? I'm going to think about adding some external forces to this player. So what I basically want to do is have a, I want to have sort of an area that the player walks into, and I want there to be like a fan, and the fan will sort of blow and apply an external force on the player, and we want to have this sort of at any angle, right? Um, if you've looked at the way we've done this, right, this is sort of the most straightforward way of doing a player controller. However, this is not going to work because every time, if we just sort of start applying forces without thinking about it, every time we apply a linear velocity to it, it's immediately going to get canceled out by whatever the move input is, right? So we have to be sort of more careful about how we do this. So let's kind of start building this out. I'll go back into here, and I'll give myself a little bit more movement. We don't have to be so slow. We'll go like here, 8, and then I can jump a little bit higher. Let's see. Okay, I'll build out a little level for myself. This is pro game design happening right here. Something like that. Yeah, why not? Okay, so I'm going to make my sort of little fan area. And go 2D object. Actually, I'll start off with an empty object. I'll call it like my fan. And then I'll have this be like a little actually I'll have this be a square. And so I'll make here, I'll make a little square. I'll call this my fan. And then in here, I'll go and I'll change the color of it slightly. Let's say, yeah, it'll be slightly green. Why not? And then I'm going to make it sort of thin-ish, and maybe a little bit wider than usual. So a very nice way to prototype stuff is to just like stick things in squares and just start going. All right. So I have my little fan here, and my goal is that when I sort of hop onto here, I can sort of like fly up, right? And so in order to do that, we're going to go and we're going to add an empty game object. We'll call this a fan collider. And then this will have a box collider 2D, which we want to be isTrigger. Who knows what isTrigger does? Who can explain? Yes.
Disables collision and just makes the vector space.
Yes, exactly. So it's used for checking when we sort of overlap with something. Here's I guess a slightly trickier question. Why would we use sort of why would we ever do raycasts if we can just sort of create and delete a box collider or whatever we want and just set it to isTrigger, right? What's stopping me from just creating a really long and skinny sort of trigger and saying this is my raycast? That's sort of yeah.
You want to make sure like the ground is actually fully to the side, so that the trigger is like on like a wall on the side.
Yes. Yeah, basically. So part of the basic idea is that raycasts are much more lightweight. They handle layer masks very easily, just pass in a parameter. They're very lightweight. They don't have all this extra data. You can just spawn them in when you need them, and then just they get rid of themselves instantly. It's just a one-shot thing, right? You want to use triggers whenever it's something persistent. So you can think of like a pickup area, or like we're doing here, a fan where you enter an area and something happens. We can also have, like for example, like a transition point to go into a new level. It's like those are things that you have triggers for. It's things that you're not spawning sort of all the time. This sounds obvious, potentially. However, some time ago, many of the Unity atrocities I have committed includes using triggers as raycasts, and it's a bad idea. It gets you in trouble with the physics engine. You start glitching through walls, and then you want to throw your laptop out the window. So don't be scared of raycasts. They are useful. Um, so okay, I have my fan collider, and you can see that it's kind of conformed to the size of this object here. So very simply, I'm going to go in and I'm going to grab this little handle here, and I'm going to extend this upward. And that's perfectly fine for our purposes. And then so you can see that when I grab this, when I sort of rotate the fan on the z-axis, it kind of moves it with that, right? Let's think about how we want to do this. So I'll make a script for this called a fan controller. And then that will create a script. The last time I have attempted doing something like this, I have done this before, like a solid year ago. So the chance of me screwing something up here is quite high. But we're going to go with that, and then I have plenty of people here to help me. So basically, we have our fan here, right? And really, I should be putting this because we want our trigger to be detected, sort of when we pass into the collider. And so what I'm actually going to do is I'm going to take this fan controller, and I'm going to remove it from the top level fan, and I'm going to add it to the collider. That way, on trigger enter 2D, we have this collider 2D, which represents the collision that we just entered. And then we're going to say if collider 2D dot compare. Oh, what am I doing? If collision dot compare tag. Compare tag player. Oh my god, I can't type today. Then we're going to start off with a very simple print message, and we're going to say player entered the fan. All right. So this is the sort of thing you have to do if you want to sort of discriminate between different objects when you're doing sort of collisions. You have to go in and you have to compare the tag, right? Which is slightly less efficient for than just doing a bitwise operation, which is what you would do with layers. So we're going to go into our player, and we're going to actually tag it as a player. And then so now the hope is that when I go into here, we'll kind of see that the player entered the fan, right? And so I actually want that whenever the player is in the fan, we're going to add a force to this player, right? So a very easy way to do that is we're going to do on trigger stay 2D. So there's on trigger enter, there's on trigger stay, and there's on trigger exit is I think what it is. And so on trigger stay is just going to continuously call. Every frame that we're in the collider is just going to continuously call. So whenever we're in the fan, I want to apply a force to the player. I'm going to simplify things a bit, and I'm going to get a reference to the player controller from here. Player controller. And I'm just going to go ahead and get that at the start. So I'm going to say player controller is equal to game object dot find game object with tag player dot get component player controller. So we're going to search the scene at the start, find the component, its player controller, and then that way whenever we collide with the player, we're going to have some function in player controller, which is going to be a public apply. I'll call it fan force. I'm a little worried about, I don't think I should be worried about a naming collision. I'll call it apply force. Apply force. And this force is going to be with some vector force. Public Oh my god, what am I doing? Public void. I told you I'd forget C sharp. Um, okay, so then when we're in here, we're going to go in player controller, dot, apply force. And then what direction do we want to apply the force? In the direction of the fan, right? So one way we can do that is to say transform.parent dot up, right? Because remember, this fan controller is part of it is part of sort of the it's the child of the actual fan. The fan points up, which is the direction that our collider is going into, so that's the direction we want to apply a force into. And when we rotate, that up vector is going to change. And then we also want some sort of configurable typing is hard. We also want some sort of configurable fan force. So we'll say force magnitude, which we can configure through the editor. And then we'll just multiply the direction with the force magnitude. And then so this is the force that we want to apply to our player. Quick question, why do I go through the trouble of sort of doing this in start? Why do I go ahead and grab the player controller at the start versus just doing it in here?
Because if you were to search every time for the player controller, that'd be very expensive.
Yes. Yeah, so exactly. It's like I don't want to, and I could just I would be fine without this find game object player tag, but even this get component, sometimes it's fast. I wouldn't trust it. I would just go ahead and go ahead and cache it. Especially as your game gets bigger, your player has a lot of components. I actually don't know the time complexity of. There's probably some fancy optimization Unity does to make sort of get component fast. If anyone knows about it, I'd be welcome to learn about it. But to be on the safe side, we'll just cache it at the start and not have to worry about it. It's the same idea as a little bit of a tangent. Camera.main. Every time I hear about camera.main, I hear something different. Some people say that this is cached internally and it's fine to do this. Other people say you should cache it yourself. I'm pretty sure in newer versions of Unity, this is like fine to do, but in older versions of Unity, this was like a massive no-no because this would like search the whole scene for the main camera. Lorenzo, do you happen to know?
I don't know, no.
I've seen like a million videos like benchmarking this, and I feel like it's different every time. I would just cache it. Yeah, it's easy. It takes like 2 lines. Might as well have control over it yourself. But yeah, so now if we go back here, so now's the tricky part, right? We have to figure out how do we combine sort of the force with the player input, right? So, right, if you think back to sort of high school physics, right, we have force is equal to mass times acceleration, right? So we're given this force, right? We're going to, for the sake of simplicity, assume mass is 1. So we're going to say force is equal to acceleration. We love how the math works out, right? So what does that kind of mean? Like, what does it mean that we're going to apply an acceleration of this with this vector to the player? What does that kind of entail? Like, what should I do every frame? Yeah. Yeah, you add that value to the velocity, but I have to multiply it by close. If suppose every frame, say this acceleration is 5, right? And I say, okay, wonderful. Every frame we change the velocity by acceleration. No, it has to do with the fact that so like let's say this game is running at like I hope this game, as simple as it is, would run at like 200 frames per second. So I'm going to say, every frame, I'm going to accelerate the player by exactly that magnitude. What problems would I run into?
It's going to get way too fast.
Yeah, exactly. It's going to fly off into the stratosphere, right? So what's the magic number that solves all our physics related problems? Exactly, yeah. Or in this case, we're going to do it in fixed update, so it's the other magic number that solves all of our problems, time.fixed delta time. Uh, so we're going to sort of apply this force, and then so we're going to have this in here, and I'm thinking if I want to, for the sake of simplicity, if I want to change this back to, because apply force, right, is going to happen every frame. I don't necessarily want to, I want to keep track of this in fixed update. So I'm thinking maybe what I want to do is keep track of whenever we enter the fan, keep track of whenever we leave the fan, and then so apply the external force on top of it every time. Kind of thinking if there's a way to, if we can keep this on trigger stay. Oh, we can just set a flag. Wait, yeah. We can just probably set a flag. Here, so apply force. Now we'll do it the other way. We'll do on trigger, enter. There's probably another way of doing this, but this is the way that's coming to me right now. We'll do on trigger enter, and we'll do on trigger exit. Right, and then so we'll do a kind of an add force, and then this would get complicated if we were doing multiple fans, but to just kind of illustrate the point, I'll do a simple add force and remove force on here. So the key here is that we have to keep track of, in this fixed update, whenever we set the linear velocity, we have to be careful to sort of treat the move input and the external forces on the fan as sort of separate components. So what I'm going to do here is, and this can get more complicated as we continue, I'm going to add a vector 2 of sort of external force. Right? And it's going to start as, sort of by default, it's going to be external force is equal to vector 2 dot 0. So we're starting off with no external forces, right? And before I even implement this, the basic idea is that we want our, instead of this, we want our linear velocity, linear dampening, linear velocity to be equal to our a new vector 2, where we're kind of taking this this external force dot x, summing that with the move input times move input times move speed, sorry. And then external force dot y plus whatever the current linear y velocity is. Right? However, we have this external force that we want to apply its acceleration as time goes on, right? So really we want this external force. We'll keep track of vector 2 and force, which will also, this is by default going to start as, this is by default going to start as 0, but just to be extra explicit about it, this is going to, every frame we're going to add whatever the fan force is plus time dot fixed delta time. Right? So we're basically treating these as different components. And then so we'll say that fan force is equal to force, and then remove force, and we'll say fan force is equal to vector 2 dot 0. So kind of what we've done here is that when we enter a fan, we're going to add a force. And we're going to say, this is the force being applied by the fan. And then so we have this external force component, which every frame we're going to accelerate the object by whatever the current force being exerted is, times time dot fixed delta time, right? And then when we actually go to set the velocity, we're going to basically sum the external force, and actually this can be a lot more explicit and a lot cleaner if I do something like this to make it very, very clear that we're doing a sum. The external force plus sort of the force that happens from our move input, right? So if I go in here, and we'll see we're not fully done yet, but this should be sort of enough to, why did I mess up? Add force. And then remove force. Should not take anything here. Okay. We'll wait for that to compile. So we're not done yet, but this should be enough for us to sort of hopefully see some interesting behavior. So I want to accelerate player. This might be way too much, but we'll see. We go in here, and woo, I fly away. I should come down eventually. Where am I? Oh, I'm gone. Right? Actually, this is interesting. This is, you see my y is going way, way up, right? Basically, because there's basically nothing to slow us down, right? So actually, I'll make it a little bit slower so we can kind of see. I'll make this like a 2, right? Actually, this has to be able to overcome gravity, right? When you see, and we keep going way, way up. And we just keep accelerating upward, right? So that tells me that our external forces are not getting reset, right? Because when we have external force and we're adding the fan force, it's like, cool, there's no longer a fan force. However, we still have external forces from the fan, right? So one easy way to do that is to just say, okay, the moment you leave the fan, you no longer have any force on you. Goodbye, force. Okay? What's this going to do? Like, what's this going to look like? Yeah, exactly. So the moment I leave the fan, I'm going to like stop in midair, right? So let's just see that happen. I go in here, and then it's barely enough to overcome gravity, and let me go here, train. You see, I immediately stop, right? Because my external forces are sort of 0. Right? But actually this is not so bad, because one thing I actually forgot about is the fact that sort of we're keeping the player's y velocity, right? So actually if we were to do something like what you said is what I thought was going to happen. I forgot that we're keeping this linear y velocity term here, right? So what actually happens is when we set external force to 0, what happens is whatever the y velocity happened to be, whatever the y velocity happened to be, we're just going to keep it, right? So if we're accelerating some amount in some direction, the physics is just going to pull us back down because we're still exerting gravity, right? Because that's handled. On the other hand, the part where what you say is actually going to happen is if I go in here, and let's make this a little bit more interesting. And then I tilt this over, right? Let's kind of see what happens there. So we're moving, we're moving. I come into the fan. You can see the moment I leave the fan, it's hard to see, but there's a stutter. There's very much a stutter there, right? Because we've just immediately sort of set back the move input. Okay, this is kind of fun. There we go. Right? Actually, Unity handles this better than I thought it would. I thought this would be a much more abrupt stop, but it does happen, right? So the way you would handle this is, I actually don't think it's bad enough for it to affect things here. But if you had to do something like, I think the Unity physics engine is helping us a lot. The only time I've ever done something similar to this was in Godot, and Godot did not help me as much. Um, but basically, what I had to do there was basically include a drag amount. So whenever you don't immediately set external force to 0, here it's fine because we're just sort of letting the physics engine take care of it. Basically, you keep this external force at some amount, and you say, okay, you have this acceleration, but there's also a deceleration component, right? You're going to have your sort of own drag component that you can add in here, and you can say something like a serialized field. Um, you can have sort of float, sort of linear drag. And what you would do is you would basically decelerate this. So you would move this towards 0. So you would say something like external force dot external force is equal to external force dot is equal to vector2 dot move towards vector2 dot 0. Or well, the current, sorry, I'm forgetting the API. External force. External force, we're going to move it to 0. And we'll do this with some linear drag times time.fixed delta time. There's a little bit more to unpack here. Who wants to kind of explain what this would do? We kind of had this. First of all, who can explain what move towards does? Yeah, exactly. How is this different from like LARP?
It uses the physics.
Kind of. It's like quite literally just a different function. So the the API for LARP is I give you give me an A and a B, and then give me some value between 0 and 1, and that's sort of where I'll be along the path between those, right? This says give me a current, give me a destination, and move some fixed amount towards it, right? So it's actually a very simple function to implement. Basically, calculate the difference in the vectors between. Now we'll do this right here. Why not? Um, you can implement move towards by yourself in like a couple of lines of code. You can do the same with LERP, but I think that move towards is even more intuitive, right? Um, so here's my A vector. Remember, vectors are, we're going to think about these as arrows with an origin, with a start at the origin, right? So here's my start, or here, I'll call it my current, right? And then here's my target, right? So if I'm at current and I'm at target, what direction do I have to move towards? What vector operation can I do to get the direction to move from current to target? Use subtract them. Current minus target or target minus? I think it's target minus target. Yes, exactly. So you go destination minus initial. So what you get is a vector that looks like this. Okay? So now I know sort of what direction we need to move in. So you get target minus square. And this is your direction, right? So I say, cool, I know how to get to my target. I just say position plus equals dirt. Right? But this is not what I want, because I'm just immediately teleporting to my target, right? So instead, right, who wants to suggest the next step if we want to implement move terms, right? To only move by linear drag times fixed delta times, or by any sort of fixed amount. What's my next step if I occur this? Normalize there, exactly. So we're going to normalize. And does anyone not know what normalize does? So this vector has a length, right? You think of it as the length of the array. What normalize does is say, give me the same vector, and you that same vector with the same direction, but with a length of 1. So it just scales the vector down. If you think about sort of how to do that, you have a vector in 2D space, just x, y, right? And if I have, here's my x, here's my y, right? Pythagorean theorem tells us that what's the length of this line? Yeah, it's the square root of x squared plus y squared. Okay, so this is the length of the sector. So if I want to take any vector of length, say this is like 5 and 10, right? Then I have to divide each of these components by the length, right? And then that gives me a vector with the same direction but of length. Okay? And what this is useful for is that now we have a vector of a known length and we can scale it to however many, right? So we have some fixed time step that we can move, right? And then so we multiply this by we have our unit vector, and then we say we're going to take that dirt and we're going to multiply it by speed. Right, or whatever the actual term for that third parameter right there is like max distance delta. Right? I'm just going to call it a speed because we have some notion of moving towards our destination. So basically, whenever we call move towards, it says, give me my current, move me some speed toward my target, and then return whatever this new vector is. Okay? So if I want to implement move towards, right, this is how I would do it. Quick question, am I done with just these 3 lines? Or is there one edge case over there? What's the edge case? If you overshoot, exactly, yeah. So basically, I could come in here, I could go here, and then, well, I move here, and then I move here, and then whoops, I move past the. So there's another if statement, which basically says, if sort of this, you would add this sort of an if statement right here before you do any of this, right? You would add basically like if the length of sure, if the length of target minus current is less than the max distance that we want to move. That's why it's called max distance delta, is because it's not necessarily how much you're going to move, it's only the maximum. So if it's less than speed, then very simply we return the target. We just don't assume it. So it gives you a guaranteed constant motion as close as possible, and you always land exactly. Okay. So the reason we're doing that for this is we have some external force, and just in the same way that we can think of vectors as some coordinates in space that kind of have this implicit arrow, we also can think of force vectors. So we have a force vector, and this force vector can point in basically any direction we want, right? So I can't just add or subtract my drag, right? Because my drag is moving me towards 0. So I can't just add or subtract, because that could be moving in this direction, that could be moving in this direction. I don't know. Basically, I want to move towards 0. All right. So no matter what, it's going to, here's my destination of the origin. No matter where my force vector is pointing, we're always moving towards 0, right? And if you look if you look at Unity, this is literally all that moves towards. So you can implement it yourself very easily. It's nice to understand. One day, I remember last year I did there was a workshop on camera movements, and there we kind of go over the in-depth between, basically, we just talked about lerp. We just talked about lerp. We also talked about move towards. There's one more that we haven't talked about, which is smooth down. I think we've also somewhat similar. Actually, does anyone happen to know what smooth down does? All right, I'm going to keep you all in suspense because we have physics to do. But it actually, wait, smooth damp actually has a lot to do with physics. It does, it's basically move towards some amount of, move towards a target, but apply this like, this like spring function to it. So it's as if you're moving towards it on like a, say you were like holding one end of a spring, right? This is like high school physics flashbacks. It's very scary, but imagine you're holding one end of a spring arm, right? And then you're dragging the spring. That spring is not going to follow super closely. It's going to have some dampening that happens. So that's what smooth damp does. It's a very scary, like, it's a really goofy approximation of like some like second order differential equation. I remember, I have to look through my slides, but there's like some textbook where they derive this function from, and they're like, here's some crazy numerical approximation that gives you basically this move dim function. But yeah, so that's the only thing that we haven't covered, but that's mainly used for camera movement, which is why I talk about it there. Where was I? Okay, so we're applying forces. So this is what you would do if you want some kind of drag. And actually for funsies, Unity's already kind of handling some drag for us, but maybe this will help us with that. So we always have some drag. So before, right, remember that whenever I didn't do this external force is equal to 0, right, I would just fly off into infinity. Now that I have some drag coefficient, what I'm hoping happens is that when we leave, we'll kind of sort of reduce those external forces back down to 0. So I'm going to go in here, and I'll set linear drag to something like, I'll set it to 10. That's quite aggressive, but we'll see how it goes. And if we fall flat like a pancake, then we know to decrease drag. And then I'll make this a little bit higher, right? Oh, now I'm like flying. Maybe we'll go in here and set this to here. Oh, now I'm flying. Okay, so I probably just have to tune the parameters. I'm not going to keep messing with the physics engine more than I already have, but this is in principle what you would do. But we had it working nice before, so I'll just take it back to how it was. So we want an external force to just be equal to 0, and we'll let Unity's drag handle that. This is probably just tuning some parameters there. Yeah, now we have this, right? If you want to add basically multiple fans, right? So what you could do is you have some options. You could have basically you could have a cumulative fan force. You could say that fan force plus equals this amount, and then you could subtract the force from here, and you could say fan force minus equals some amount. So you have minus equals this amount, and this would get you that effect, and we could sort of add all of these. And I believe what I would want is external force should also minus equals force. I have no idea whether this will work or not. We'll see. We'll add force, and then we'll just kind of see what happens. The nice thing about like, we'll copy this over. The nice thing about like physicsy stuff is that there's no. It's just like if it plays well, if it just kind of moves how you expect it to, it's like it looks fine to me. Let's go in here and let's duplicate this. I'll duplicate the fan. And I'll move this over here, and I'll kind of make them cross over each other. Let's see. Let's see how that looks. Just mess around with it. Some kind of ooh. That's not what we wanted. All right. Let's see if we can think about this. If we can't, then I might move on. Does anyone have any ideas? Yes? Okay. So are you saying to move this into like here?
Yeah, like external force would just be like accumulating the force, and then the time fixed delta time is applied after the fact. Like you don't add it to the external force, you just multiply the accumulated man forces.
Oh, after the fact? Is that I think you have to like multiply these terms together, right? Because if you have some I want to accelerate in some direction, right? How much I accelerate per frame is going to be equal to this. Let's try apply force. But I want to try sort of what you said, whereas we just kind of stick this in here. And we'll say that like so first, and then we would definitely need to add our drag back in. But were you a fan force minus equals? I suppose external force can't be less than some amount. Oh, shoot, I should clamp this because if we enter a fan, right? What might happen is I might exit the fan, right? At any point, and I don't quite know when that is, right? I don't quite know when that is. However, we might not like if we exit when the external force is sort of low. So if we quickly enter and exit, we're just going to slam the force back down. Does that kind of make sense? So I think what I have to do is actually subtract by however much the accumulated fan force was for each one. You could probably have an array for this. Actually, that's definitely not the right move. So you have to somehow subtract the contribution of only that fan. Yeah?
When we're doing RB at linear velocity equals an external force plus the movement, is that overriding the linear velocity or is it this or is it setting it after like modifying?
So this just overrides it because we have whatever our accumulated external forces are, and then we have whatever the force from our input is, right? So the tricky part here is how do we how do we separate the force that comes from this fan, right? And basically just take it off, right? That's an open question. I don't know. Let's see. But this is something to think about. What I'm thinking is you would have to somehow keep track of. You have to somehow keep track of how much force each fan applied, right? Actually, might as well try this. This seems interesting enough. We'll go back to add force. And maybe what we can do is have each fan keep track of the force it's applied to the player, right? So we can maybe do something like this will be just an internal float. Applied force is equal to, this will be a vector, vector 2 applied force is equal to, if we do some sort of vector 2, 0 here, and whenever we sort of apply this force, we'll keep a Boolean flag. Force. And there's definitely a more elegant way to do this, but I'm curious to see if this works. So we'll say applying force. Oh my god. Applying force, applying force is equal to true, and then here applying force is equal to false. Here applying force is equal to true, applying force is equal to false. And then, so when we are accumulating forces in our fixed update, what we'll do is we'll say if applying force, then the applied force is just going to once again increase by this amount time dot fixed delta time. And it doesn't like this because it's a vector 2 versus a vector 3. So we'll go in here and we'll say, cast this to a vector 2. Oh, it says reorder operands for better performance. Yeah, sure, go ahead. Okay. And then, so here we would have our applied force be 0 whenever we exit a fan. So each fan is keeping track of how much force it's applied. And then we'll keep another accumulated force here. And then so the external force is going to subtract the accumulated force. That way we're not flooring it down to 0. Let me see if this is reasonable. Applied force. So the applied force of this fan goes down to 0 whenever we exit, but then sort of the external force in total applied to players minus accumulated force. Let's see if this works. And if it doesn't, then I officially give up. That's more reasonable. Did we win? Did we do it? I'm going to call it. I'm happy with that. So that was very improvised, but does the solution kind of make sense to everyone? Like why we did what we did? This is why I don't plan things out of time. But so whenever we exit a fan, right? So you can see when I go right in between that sort of cross area between the fans, I kind of fly upwards because their forces are kind of accumulating. But whenever I exit a fan, right, we only subtract the external forces of that one fan's contribution. Are there cleaner ways architecturally to handle this? Yes. Here we're making a lot of assumptions about like, okay, we're only going to have fans. Actually, let's talk about it. If we want to generalize this, right, what are some steps we might take if we want to just have literally I walk into any trigger and it just applies forces and it just works, right? Um, how might we do that? Like, what are some sort of what are some what's a cleaner way we could handle this? Yeah. How would you have actually this is worth talking about. So like what is the alternate implementation? Actually, if you want.
Well, I don't think I have anything worth right now, but my problem is this is the fact that you're calling
Mm.
fans and player controller. For me, I feel like inside the player controller should only be player controller as things. If you have
Mm.
fans and then you have other things that add forces, and you don't want all those, or
Yes.
like simply add force or remove force. What I would do is for since we're like leaning into fully physics-based movement,
Mm.
for jump, I would just add force in impulse mode, which is
Yes.
not yeah. And then I would just have the fan apply the force to the objects in the fan
Mm.
script, making it like separate for
Yes.
the um, making sure that all the forces that the player does,
Mm.
it doesn't really matter what external forces are being on it because it'll just go on top of it,
Yes.
I guess.
Right. So yeah. Wait, I didn't mean to cut you off if that was the idea, um, but yeah. No, so okay, Unity has a built-in RB dot add force where you have some external force, and as you mentioned, there is a force mode 2D where we have force mode 2D and we have force and we have impulse. Force is basically what we implemented. It's some constant acceleration inside of the frame. Um, we also have impulse, right? Which is just add this force as a kind of burst. So what you were saying is a jump is kind of like an impulse force that you just apply. Um, my question is, how would you handle horizontal movement?
Horizontal movement. Um, well, with my physics, you just add force.
You had a force, yes.
What would be wrong? Because then that would just add with all the other external forces. No?
Yes, but when we think of player movement, we don't typically think of it as like there's some acceleration towards.
I see what you mean.
It's an instantaneous change in
Because like
velocity.
if I hold it, then well, yes, it depends on the game. Like for example, Super Mario Bros.
Mhm.
3, when you walk, you just accelerate a little bit to top
Yes.
speed, and then when you let go of the button, you'd still go and slow down.
You slide, yeah.
It just depends on what kind of game.
This is also very true. So if you have like a fully sort of physics-based game, what you can do is use just everything as a force, right? Because like if I walk over there, it's not like I'm setting my instantaneous velocity somewhere. It's like I have to pick up my legs and apply a force with my legs, right? Um, so what you're saying is true. For certain games, we want to. You mentioned Super Mario. Whenever I hold the right mouse button down, I accelerate with some force, and of course we have to clamp the force because I can't just keep accelerating to infinity. So you have to limit the force. You have to say something like, my acceleration due to or my velocity due to movement can't exceed some amount, right? So you apply the force up to an extent. Um, and then when I release it, that built-in Unity sort of linear drag is going to kick in and do that. Um, well, that's just nice because it plays with the physics system, right? Um, does anyone have like so the tricky part here is that we're combining sort of two ways of doing things. One being there's an instantaneous change in velocity whenever I hold, right? Which doesn't really it doesn't really play nice with sort of how physics would work in real life, right? Because like acceleration is infinity basically, right? When you do something like that, you could use a very high value. Um, Also, how do you clamp the velocity? Um, so you absolutely could do it that way. You could also do it this way, where you just handle them as separate components. You had a slightly deeper point, right, about separation of concerns, right, with the player. Basically, so this is in the player controller, right? And your objection was to these two methods?
Having a method called fan force in my player controller is like
Yes.
giving the alarm arms in my head.
Yeah.
I don't think that should be handled in player
Yeah.
controller.
I agree with you. What about this?
Yeah.
I mean, I see what you mean, but if we wanted to, because there's nothing special, particularly special about fans, right? It's just some collider that exerts a force in some predetermined direction, right? Um, so we can say there's some, I guess external force and object force. This is wonky naming, right?
Uh, what's the advantage of doing it this way rather than in the fan controller script itself? Getting the collider, being like, yes, this is a player,
Hmm.
and then getting the player's rigid body and adding force in the fan controller itself rather than calling methods.
Oh, to say just RB dot add force from the.
From the fan controller itself.
Mhm.
From
Well, exactly. So if we were doing basically what you had suggested, which is sort of we'll handle everything with forces, right? But if I literally just call RB dot add force from an external object, right? Without doing this, where we're combining the vectors and setting the velocity manually, that add force will get immediately overridden if we do something like this.
I see.
Yeah. Because add force will just sort of tweak the RB dot velocity over time, but it's like we're kind of fighting over this, right? It's like the player really wants to the player controller is fighting with the fan in that case, right? So that's basically the reason behind just stick it all in player controller and let player handle its own physics. Um, it would be really nice if we could just handle everything with forces, right? Does anyone have like any ideas of like if we wanted to sort of instantaneous change in velocity and we want to we really just want to do what Lorenzo says and say just RB dot add force, right? How would you sort of do that?
The thing that instantly comes to mind is instead of just like applying force, you
Mm.
just add or subtract to the linear velocity. So like when you press right, instead of setting it to x speed, you just
Mhm.
add that to the x speed. So if you have a force that's pushing you at a certain velocity rate,
Mhm.
and you press right, then it'll add those two velocities together, so you get pushed and you get that instantaneous from the movement.
Yes. Um, However, that now becomes when you do that. So if you say RB dot linear velocity equals whatever my current velocity is, and I'll just say I'll add like 10 to it to the right, for example. Uh, that 10 that you just added gets added back to the rigid body's velocity, which is what you read back next time you're holding.
Oh,
Right,
no,
if
I
that makes
meant
sense.
like when you press the key down,
Yes.
it applies it one time.
It applies at one
And then
time.
when you key up, when it moves, like it subtracts that from the force. I don't know if that'll work.
So we're essentially having different components, right?
Yeah.
For yeah. So is that similar to what we do here?
It's only what we do with the force, like where we're adding the force. When you add force, you do plus equals force,
Mhm.
and then when you so remove, you just do minus equals. But
Yeah.
instead of forces, we're doing the velocities.
Oh, so you reverse this.
Yeah.
You say, okay, you say, we'll use RB to kind of add all of this, and then we'll do sort of these instantaneous changes as we'll keep track of those as a separate option. You'd also do that. And this would allow you probably to do what Lorenzo said and literally just call RB dot add force, and you could handle it that way. Um,
Like from a
Yeah.
physics perspective, like what immediately jumped out of like from like high school physics was there like a new velocity equals initial velocity plus AT. So like
yes.
that initial velocity could be your instantaneous thing changes, like
Yes.
with the movement, and then that AT is what the actual force is applying.
Hmm.
I don't know if that's actually how it works. I'm just what I remember.
Yeah, I mean, is there such a thing as instantaneous velocity in the real? It is, but it's video games. We can do what we want. Um,
If you
yeah.
really want just a quick and really not a bad solution, a solution that gets the job done.
A game jam solution.
A game jam solution. What you could do for a horizontal
Mm.
is simply just change the X position incrementally.
Ooh, yeah.
That That works. It's not the
That will
prettiest,
work.
but it'll
Will
it'll
that
limit its scope.
will that work? Yes.
I'm just remembering. So, Texas Game Jam, we actually did something similar where we applied force.
Hmm.
We had like oil on the ground, so when you
Yes.
land on it, you would get like an acceleration
Okay.
rather than linear speed. So, I think the way we did that was literally have an acceleration like parameter in our player object, and then we would just add to that acceleration parameter.
Hmm.
And so when we did the calculation for the new velocity, we would multiply that by delta time and apply it to the older velocity, which is our instantaneous uh, velocity that we added, pretty much, or like added when we key down and removed a key up.
Yeah.
And that gave us that illusion of acceleration, even though we were just kind of updating it every time based on what our current conditions.
Hmm. So you can also have access to the transform. You can literally just move the
Yeah,
transform.
exactly.
Um, does that, wow, does that, uh, that feels like they would like fight, right? Between, like, because they would both, because the rigid body wants to fight over um, position, the, uh, but also your code is also applying things to the, but I suppose it doesn't matter because you just have separate velocity components that are sort of getting added together. Um, yeah, why not? Like, literally, yeah, why not? Uh, eh, it might get complicated because you can imagine that getting tangled if you want to, yeah. But that would, as you said, that would kind of only really work for horizontal
Yeah.
movement because if you, the moment you try and do that with, you're kind of recreating gravity there. If you try and manually set the transform, so you're kind of locked into one axis there. But no, that's a good point. You could absolutely do it that way. Um, but the whole challenge here is that we kind of have these two things that are sort of all competing and fighting over this one RB dot linear velocity variable, and how you choose to separate that is kind of up to you. Um, I really like the idea of separating out, sort of reversing what we did here, with just keeping track of the instantaneous velocity and um, and sort of handling forces the unity way. Um, but yeah, this is also a way to do it if for some reason you find yourself stuck and you really need to handle this otherwise. Um, but yeah, no, all very good points. Um, cool. I mean, we have fans now, so absolutely all worth always all different things worth experimenting with. Um, any other comments on how we could have done this? Uh, any alternative explanations? Yeah, but no, all of those are very good. Let's see. I was just going to keep bobbing up and down. Sure. Um, and you could expand this to include lots of different things. We took a very sort of manual route with doing this. As y'all have pointed out, the engine will do a lot of heavy lifting for you when you do this sort of thing. So, for example, we already looked at sort of rb.addForce, which has rb.addForce, which has some force, some vector, and then you can take in the force mode of either impulse uh, or um, or force, which I think is just the default. Um, we also have these handy little things called force effectors. So actually, if I'd have gone here, I think Unity has this by default, where if I go in here and I go into, let me just go and sort of disable this effector. There's an area effector 2D. There's a platform effector 2D. There's a buoyancy effector 2D. There's a point effector 2D. Um, does anyone kind of, I mean, can you all kind of guess what this does? First of all, what do y'all think platform effector 2D might do? These are sort of modifications that we can do um, to these standard sort of 2D colliders. Have you ever used these, Renzo?
Area and buoyancy makes sense to me. Platform, I'm trying to think of what that.
Yeah. You know in like the in platformers where you can kind of jump below a platform and land on top of it.
Oh, like one lens?
Yeah, it's one-way collision.
I see.
So that's what that's used for. Um, Buoyancy is pretty self-explanatory. You can put this over an effector, and then when a rigid body collides with it, it's almost as if it's floating on water. So you could have sort of a bunch of visuals, however you want, for water, and whenever your rigid body lands in, it sort of handles the buoyancy physics for you. Um, there's also a point effector, which I believe does pretty much exactly what we were doing. Um, so we have this collider mass, which tells us whatever we want to affect, and then we have this this force magnitude, this distance scale, which I believe you would literally just set to like -1 or something. Um, ah, Point effector, and then force, and then you have some damping. And then all you do to include these is literally you have a use by effector, and it'll by default bind to this. You could also have an area effector, which I believe what this one will do is one of these is used, it's either point or area for, I think area does what we want with the fans, and point would do something like gravity, if I remember correctly. I have no idea. I haven't used force effectors in a while. I tend to prefer doing these things by scratch, because if we were to just slap in an area effector, what would happen is our instantaneous velocity would immediately conflict with that, which we can handle that in different ways. Like you said, we just keep track of that separately and sort of set the rigid body manually at every frame is like whatever it is plus whatever the instantaneous velocity is. Unity will kind of do a lot of the heavy lifting for you there. What else is there? Buoyancy effector, surface effector. Y'all can read about these. I will be very honest. I can't remember the last time I've used an effector. I definitely have used them, but I don't immediately reach for them. You just kind of get less control over exactly how things behave. I think it's worth sort of doing these, by hand. Yeah. Does anyone else have any questions? We're at 7:44, so we're in kind of the last little discussion time. That's pretty much what I wanted to implement for this workshop. So if any of y'all have like any questions, if y'all want to keep talking, I will hang around for a few minutes, and then other than that, y'all are free to go. But if you have any questions, I will be up here. Yes.
Yes, thank you for this class.
Yours?
From my experience, and it's important to mention the performance when you are building your game.
Yes.
It's very important to put focus at the beginning.
Yes.
Because I make a mistake and then I took several months really happen.
Yeah, exactly.
Important. And the second one, always to ask how to scale up the code. Like jumping, your farming.
Yes.
How can I have a good code so I can implement different kind of arms or different things? Because otherwise you will get a lot of code.
Plus, yes.
Things will broke at the end. So those are important questions on how to do it better. How to give time to ask those questions, like which is the best way to do this. Those questions are important.
Yeah.
In the game. Example.
Yeah, of course. Yeah. To kind of touch on that point of scale, there's kind of two kinds of scale that you mentioned. One is like, sort of how do I add variety? So like, if I want to have different types of fans, right? So that's sort of the organizational part of scaling. Of course, Unity gives you lots of tools for doing that. One nice and simple trick of just conventional object-oriented wisdom is to have some kind of interface, right? An interface which says I promise to implement sort of an apply force method, and then I can take an input from any kind of sort of force effector, and the force effector itself will sort of handle its own implementation. Performance, of course, is also super important. And when you start to sort of scale these up, um, you could absolutely get problems with that as well. I think for in this particular case, I can't think of too many issues with like if I were to just take these fans and duplicate them 100 times. I think the main problem would just be like if I have a fan on some other side of the map that I don't care about, I might as well sort of enable it or disable it, right? Um, but in terms of the actual work we're doing, um, these are all sort of addition, subtraction, right? Um, this is having to keep track of its applied force, but only for the fans that are currently interacting with the player. Um, so if you want to scale this up, one thing that I think would be important is to probably sort of disable fans that are sort of far away from the player and not really worth keeping in memory. And that extends to sort of any large level, right? Is to sort of enable, disable what you need. Um, because of course the memory cost is going to keep increasing and increasing. Um, but absolutely, of course, it's important to keep that in mind. Um, Anyone else has any performance considerations that I might have missed for this particular use case? But yeah, yeah. If anyone else has any questions, I will be hanging out here for the next 10 or so minutes. So yeah, thank you all for coming, and I think this is our last workshop for this semester, but I hope to see you all back.